We are on 6.2, problem 3, page 388. Last new thing. After this, everything in that homework packet you should be able to do. Once again, this today after school, last time for late work. Hello? Which chemistry? 14C. I don't know what the name is. Yes. Yes. All right. Perfect. Bye. Okay. Algebraic method. Top of the page 388. Jerry, would you read for us? Oh, you got a mouthful?
Still read.
Okay, good.
I can read. I can still read. Page.
The algebraic method you use to solve the linear systems in problems 1 and 2 are called the linear combinations method. The linear combinations method is a process used to solve a system of equations by adding two equations together, reversing an equation with one variable. You can then determine the value of that variable and use it to determine the value of that other variable.
Brody, in many cases.
In many cases, one or both of the equations in the system must be multiplied by a constant so that when the equations are added together, the result is an equation in one variable. This means that the coefficients of either the term containing x or y must be opposite.
Okay, the coefficient must be opposites of one of them, not both of them. Either the x or the y, you need to get the coefficients opposites. What does opposite mean?
Not the same.
Positive and negative. It's more sophisticated than not the same. There's a lot of versions of not the same. But they actually need to have the same value, but one positive, one negative. Same absolute value, one positive, one negative. For example, look at the first equation they give us. If we leave it like it is and I add straight down, I've got 4 plus 5. Tony, off in La La Land, what's 4 plus 5? 9. That doesn't cancel out. If I add straight down, I've got 2 plus 3. Christian, what's 2 plus 3? That doesn't cancel. All right, so adding straight down right now doesn't cancel either variable. So look what they did. They said, let's multiply by a positive 3 here and a negative 2 there. They have to do it all the way across the x's and y's. Everybody, I need your eyeballs up this way. And they have to do it on the other side of the equation also. All right? See this 3 and this minus 2. Here's what ends up. What do you notice? What do you notice?
6y cancels out.
6y is going to cancel out. They're both 6. And one's a plus, one's a minus. Guillermo, why do we need a plus and a minus right here?
So they can make them the same.
Well, they're kind of the same, but kind of different. So why is that helpful? When we add, what's going to happen?
Oh, 3.
Wait. That's Guillermo. When we add these two, what's going to happen? Well, what? Cancel out. So, Christopher, positive 6 minus 6. What happens when you add them? They cancel out. Were they, take a look at the first y's. Were they 6 and minus 6? No. So we had to decide what to multiply them by to get them to be 6 and minus 6. We had to multiply here by a 3 and here by a minus 2. And a key is up here in the last piece of what was read. Must be opposites. Everybody put a cloud or an underline or a box around that idea. We need to get one of the variables to have opposite coefficients. Doesn't have to be both, and it doesn't matter whether it's the x or the y. We need, as we cancel, for one of the variables to cancel out. Now, so far you've had equations where that's been decently easy to find, or you were able to do it yourself. Just yesterday we saw one where you had to multiply a little bit. In these, you had to multiply both. Solve the new linear system. A little bit smaller so I can fit it in. Here we go. Here's our new system. We add them together. Goodbye to the 6's. 12 plus negative 10. 9 plus negative 8. X equals 1/2 because we divide both sides by 2. We have to go find y. We can put y into this equation, or one of these two up here. I think I'm going to pick, you can't see up there because I made it. I think I'm going to pick this one to put it in. You have a choice. But I can see I have a 1/2, and I'm going to put it in front of a 4. I can take 1/2 of a 4. I know I can do that. So I'm going to go 4x plus 2y equals 3. I'm going to replace the x with what we found for x.
2.
Good, Brody's on it. 4 times 1/2, or 1/2 of 4 is 2. Thank you, Jerry, for confirming that. Okay, now we got to get this y by itself. So the first step is get rid of the 2. Now we have
Y equals 1.
2y equals 1. So what does y equal?
Division time.
Division time, divide by 2, divide by 2. Y also equals 1/2. So here's the x coordinate. There's the y coordinate. We always have two answers. A lot of times we'll take them and put them into an ordered pair. Remind ourselves.
I can do it blindfolded.
Good. Now, number 2. Andy, could you read the directions, please?
Number 2, yes I can. Describe the first step using the solving system using linear combination method. Identify the variable that will be solved when you add the equations.
All right. They got them side by side. I don't like it side by side. The first thing I'm going to do is stack them so it matches what we've been doing. Let's bring it up a little higher here. I'm reminding us that we're looking to cancel when we add straight down. All right. Now, one good thing is I do have a 2 in front of all the y's, but are they opposites? No. So I'm thinking about a factor I could times through by to make one of those 2's a negative. What do I need to multiply it by if I want to make a positive turn negative? That's what I want to happen. What do I have to times by?
A negative.
Negative 1. It doesn't really matter whether we do the top or the bottom. I think I'm going to do the bottom. I like the looks of that. I'm going to multiply the bottom by negative 1. I'm going to rewrite this whole system over here. The top one I'm not changing. The bottom one, I'm going to distribute this negative 1 through each piece. So right here, negative 1 times 3.
3.
Negative 3, right? Negative 1 times 2.
Negative 2x.
Woohoo! Good job. And then all the way across equals negative 1 times 6. They don't ask us to solve this. They just said identify the variable they just say identify what needs to be done. Identify the variable that will be solved when you add. Let's just identify what's going to cancel out. We've got a plus 2, a minus 2. When we add, that will cancel out. We're not going to solve these yet. We've got a couple on the other page to solve. Okay, again, let's start by stacking them. It's a little easier to compare. it's still high enough for you to see. All right. Now I look at the x's and I look at the y's, and nobody matches. Okay? So I'm thinking about this. I also see this x doesn't have anything. I'm going to remind myself that's a 1. I need to make one of those variables that when I line them up, one's a positive, one's a negative, and they both have the same number. I think I could multiply here and here by something. Wait a minute. I think I'm going to work on this one. I'm going to make this stay positive 5 and turn that one into negative 5. What do I have to times by to turn that into a negative 5? Negative 5. Okay? So this time I'm going to go like this, and I do need the negative just like before, but also I need a power or a factor of 5. Okay? Now, I'm going to look at what's done when I do that. Negative 5 times 1. Negative 5 times 3.
Negative 15.
Woo!
What?
Brody had a good sleep. Negative 5 times 15. You have calculators?
Oh, 5.
120.
A little too big.
75. 75.
Negative 75. Okay? Now the bottom equation, we're not multiplying by anything. We're just going to bring it right on over. 5x plus 2y equals 7. I'm going to identify that when I add those two, the x's are going to go away. They're both 5 now. One's a plus and one's a minus. Okay? You guys, well, let's see. How hard does this one look? I hate it. They don't give us enough space. Do I write too big? Their space is small.
No.
Do it on the side.
Good idea, bro.
Is the side... Oh! We're going to have to multiply both. Do we want to cancel out x's or do we want to cancel out y's?
Cancel out y's.
Okay.
7 times 1 by 2, a negative 2, and then 1 times.
He's saying, I'm going to make 6. I'm going to multiply 1 by a 2 and this one by a negative 3. He can see that it'll be easy to get these to turn into positive 6 and minus 6. Times by 2, times by 3. One of them had to be negative. It doesn't matter which one. Now I ignore the bottom for a minute and I just think about the top. 2 times 4. 2 times 3. That was a very delicate little sneeze. 2 times 12.
What do you felt?
And that's a place to remember. Sometimes people focus on the x and the y. They forget to do the other side, the equal sign. Now we're going to ignore the top, just work with this negative 3, multiplying it across the bottom. You guys go ahead and multiply, get what it's going to look like on the bottom. Oscar, what's going to cancel out? The x's or the y's? Oscar? Try again. When I add these two, are those going to cancel?
I thought it was a 9.
Okay. When I add these two, are they going to cancel? Can you see them, Oscar? I know that's far away for you. Why are they going to cancel?
Because they're opposites.
Opposites. One's a plus, one's a minus. Good. There we go. All right. Top of page. Oh, where did it go? There it is. Focus. Oh. Do we have to multiply?
No.
No. Here we go. Goodbye to Y's. Brian, what do I do next?
You divide by 5.
X equals 3. Am I done?
No.
Christian, what do I do next? Put it in somewhere. Which one would you like to put it in? Top one.
Good choice.
Whatever you get for the X, you replace it into one of the equations. You can pick which one you like the best. Then you start to simplify. And you want to get the Y by itself. And then you usually express your answer as an ordered pair. All right. Now, B is one of our new ones. One of these we need to multiply. Which one should we multiply? Bottom one, I hear. What are we going to need to multiply the bottom one by? Excuse me? Do I hear -3 out there?
Yep.
Okay. It's very shy and quiet. I put it off the back this time because I didn't have room. Top equation, I'm just going to rewrite. Bottom equation, I'm going to times by a -3, times by a -3, 3 times 3, -9x, -3 times y, -3 times -2. -3, +3 cancels. Add these guys. Add these guys. Can you divide? What's 30 divided by -5?
-6.
-6. Ordered. Oh, we're not done yet.
Gotta find X.
Gotta find X. Which formula, which equation, top or bottom?
Bottom.
3x.
Mr. Grady,
Yep.
you're solving for Y. You mislabeled.
Oh, okay. That's X. Good. Thank you. Good, because that would have made a problem over on the next step. Thank you, Jerry. Okay, so now we're still going to use the bottom equation. 3 times -6. -18 plus y equals -2. Ernesto, how do I get y by itself? I want to get rid of this 18 and move it over there. It's a -18. How do I cancel that out? Add an 18. Y equals 16. So my ordered pair, make it a little smaller here, is -6 was the X, 16 was the Y. You go ahead and do C. I'm walking around at your table. Decide, are we canceling X's or are we canceling Y's? Do the multiply. Rewrite your equations.